I believe my screen is now visible to all of you. Yes. Okay, well, thanks for being here. I want to talk about web applications of the future. And this talk will be heavily about TypeScript, GraphQL, also some React, but you don't need to have any React knowledge in order to understand what we'll be talking about, because most focus will be on GraphQL and TypeScript. So who's this talk actually for? And for this, I want to ask some, I want to have people some idea about what this talk will be about. So for this, I always like to think about, if you start talking about TypeScript and GraphQL, what is actually a date? So a date can be many things. So it can be actual the date in a few weeks. In a few weeks, we'll have December 7, which is a date. It happens every year, and it's a few days after Sinterklaas for those from the Netherlands. But a date can also be a fruit, which is always something to consider about. So even when thinking about programming, dates can be multiple things, but even in real life, a date can be multiple things, because we have an actual date of a day, but we also have a dried fruit. And with that dried fruit, you can even recreate the word date. So that's another example of what a date could be. So we have an actual date, we have a dried fruit, and we have the word date. In the programming, it's the same, and you might even have metaphors for certain things, because this is also a date. So we have all these examples of what a date can be, and these examples are here in real life, but especially in programming, when you're writing code, when you're thinking about modeling maybe even a database, dates can be lots of things. So even if we look at some, this is JavaScript, I think. Even if we look at some basic JavaScript, a date can be lots of things. It can be a date object from ECMAScript. It can also be a string, so a string of some kind of a parsed date literal. It can be a timestamp, of course, and it can be many other things. It can even be an object in which you define values for the day or the month or whatsoever. So a date can be lots of things in life and also in programming. And that's why I always like to work with technologies that have a type system. And if you have no knowledge about type systems yet, that's also fine, because I'll be explaining what a type system is. I'll be showing you about type systems in TypeScript, but also in GraphQL, and how they can work together, because that's the nice part of what I'm going to show you today. And that's why these technologies are so powerful together, because they really help each other in getting most of the value you want out of your application. So a little bit about myself. So I've been at a meetup before. I think it was maybe 2 years ago, with some nice Chinese food. So my name is Roy. I'm from Amsterdam. I'm an entrepreneur, a software engineer, author, and speaker. I work a lot with things like TypeScript, JavaScript, GraphQL, React. I work with multiple clients, and one of those is Stepsen, which is a tool to create GraphQL APIs, which I will show you later. And also I give trainings through my own company called Hackteam. And also you can find my courses and talks on the website. If you would go to hackteam.io, you can find some of the books you can see there, and also the talks. And in general, if you like to know more about what I'm doing, just follow me on Twitter. If you're not on Twitter yet, it's a great source to read about a lot of nonsense, but also about what's going on in the tech world, what are new technologies, but also all the things surrounding it. So think about Web3 or NFTs, all these kinds of things. Those are nice conversations you can find on Twitter if you're into those kind of things. So if you're there, follow me and let's get connected. What do you already know about TypeScript? And as we have enough time, if someone wants to tell what they know about TypeScript, then please unmute yourself and let me know. And if not, that's also completely fine. I will just continue with the rest of my slides.
TypeScript adds the type thing that we don't have in JavaScript, in vanilla JavaScript. Like a variable can be a string, a date, or anything, but in TypeScript, we can declare the variable of a particular type, and it can only hold that particular value.
Yes, indeed. So You can see TypeScript as some sort of a, well, some call it magical, but in the end, it's just a configuration layer around JavaScript, and not really JavaScript, but most of all ECMAScript. And well, let's see what that means. So if you start thinking about TypeScript, you should also think about JavaScript, because TypeScript is actually a type superset of JavaScript. So it's not really an extension or something. It's also not a plugin, but it's really a type superset. And if you want to know what a superset is, it's actually a definition coming from computer science books. And a superset is a programming language that contains all the features of a given language. So that's something that's important to understand. So TypeScript has all the features that a given language has. And the given language in case of TypeScript is JavaScript, and most of all the ECMAScript specification. So TypeScript will always follow the latest ECMAScript specification. And as soon as something comes from a pre-release version to actual ECMAScript release, it will also be included in TypeScript, because TypeScript is a type superset, and it will make sure that it actually follows the language that it's expanding or enhancing. So that's a nice part. If you look at TypeScript, it's expanding on JavaScript or ECMAScript, and it's adding the types to it. It's not adding something else. So most of all, it's just adding types. It's not so much adding extra features. So you won't see, if you think about constants or variables or let variables in JavaScript, TypeScript won't change these kind of things, or they won't add a fourth type of variable. Instead, they will enhance them with types. And you can find more type supersets if you look at programming language history. Look at all different versions of HTML. At some point, you had also variations on HTML, even though it's up for consideration if HTML is actually programming language. But in general, it happens more often that there are languages created on top of or next to other languages that are really following each other. So you can kind of see it as when you fork a repository and you keep your things in line, and you're actually building upon what somebody else built without changing what they built. That could also be a form of a superset. And also, what I like to say about people that might be a bit hesitant about using something like TypeScript, please look up the creator of TypeScript. So he's working at Microsoft. His name is a bit hard to pronounce because it's very Scandinavian, but it's something like Andres Helsberg. And what he's doing at Microsoft is super cool, because he's building TypeScript. He's making sure that it's following the ECMAScript specification. He's also making sure that it's working super fast for developers. So the VS Code extensions, an example, are very good. So if you work with VS Code, then it's really nice to work with TypeScript as well, because the extensions are really good aligned. And he was also the creator of other languages like Turbo Pascal. So if you are here from the early days, then you might recognize the name. So that about being a type superset, and this is something we'll also see later on when I show you a demo about what you can do with TypeScript. And what's also good to know is that TypeScript compiles to plain JavaScript, because in order for your browser to be able to understand what's going on, it needs to compile it to plain JavaScript, because a browser typically can't read JavaScript. Sometimes it can, but usually it's even compiled by the browser itself as well. But it specifically can't read TypeScript. So it needs to be compiled to plain JavaScript in order more systems can understand it and work with it. So what does it look like? On the left side, you can see an example of TypeScript. And whenever you start working with TypeScript, you typically create types. And there are multiple ways to create types. You can either define them as types, but also as interfaces. And it's kind of the same, except for the interfaces are easier to extend or to build upon, even though you can also build upon types. So it's very similar, and most people don't even get to the point that those similarities are actually making a difference for what they're trying to do. So in general, try to think about that whenever you're writing types or interfaces in order to define a type. In TypeScript, it's pretty much the same, and there are some differences, but most people won't even notice. So I typically go with type because I'm writing types, So for me, types feel more, it feels better. So you can see I've written down a type called fruit. It has two fields, a name and a variety. So you can think of maybe you would have, well, a fruit called pear, and the variety, well, it could be what kind of fruit it is, because you have fruits with, well, there are multiple ways to define fruits. I won't go into detail about it, but you have multiple types of fruits. So assume we have an apple or a pear. You would have a function to create an array from another array, and maybe instead of mapping all the fields, you just want to create an array with strings. So you can see we now have an array with an object. So you would have fruit with a name and a variety, and the output would be just an array with just strings, so just the names of the fruits. So if you build it in TypeScript, you have to append or actually tell TypeScript what the types are. And you don't have to actually tell them what the types are, because otherwise it will try to interfere it, which I'll show you later, or it will just think it's anything, which won't add any value for you, because then you can just use JavaScript instead. So on the left side, you can see that the input for a function is an array with the type fruit, which will mean it is an array of objects, and that object has two fields. And the output, you see the output isn't actually defined, because TypeScript will already know it will interference and will see what the type will be in the end. So it will see that if you do a map on top of an array of objects and you only return a string, it will already know that the result will be an array of strings. And if you do this in JavaScript, it definitely has no idea what's going on, because whatever you're mapping, it can be an array, it can be even an object, and then probably whenever you run it in your browser, you will get an error. With TypeScript, you will already get the error whenever you try to compile your code. So as soon as you save it, it will try to run it, you will get the error, because it already see that you can't map over something that isn't an array. You can't map over a string, in example. There are other things you can map over, but you can map over an array, and if it's something else than an array, it will probably return an error. So you can write it both on the left side, which is TypeScript, or on the right side, which is JavaScript. But the output of whatever comes out of your TypeScript compiler will always be plain JavaScript. So it will make sure it's readable for the browser. So if you think about TypeScript, it's basically just JavaScript and you add type. And by adding the types, you will make sure that you both have easier introspection. So whenever you click on something in VS Code, and for other editors as well, you can often see what kind of parameters a function takes, or what could be the aspects of a certain object. So this is something you can see with TypeScript, but in the end, whatever TypeScript compiles for you is readable for the browser and should be JavaScript. And then, of course, you can also tell the compiler if you want it to be ECMAScript 2015, or ECMAScript 2016, or ECMAScript 2020, whatever you prefer. And also, it uses the latest ECMAScript features. And as it's a typed superset, it will make sure that it keeps following the ECMAScript features all along. And this is specifically useful for you to know, because that way you still have backwards compatibility. But as soon as something changes in ECMAScript, you don't have to worry about how it is handled by TypeScript. And to give you an idea about the size of TypeScript, so TypeScript is well, getting more and more popular every day still. It isn't growing as fast as it was 5 years ago, but still it's going strong. So this is a screenshot I took today or yesterday from the NPM page of TypeScript. And you can see it has well, almost 25 million weekly downloads. It's already on version 4.5. And you can see it's, well, new versions are published quite often. And now you know what a type system is for TypeScript. You can already start thinking about, and you probably know the answer to this as you saw the title of this talk. So we know TypeScript is type, but what else has types? And it's of course GraphQL, because TypeScript isn't the only language or the only programming language we know that has types. GraphQL also has a type system. And to know about the type system of GraphQL, it's useful to have some knowledge about the type system of TypeScript, but those things are very, well, they have some similarities, but they also have things that are different, which I will show you later on. But first, we're going to have a look at GraphQL. And maybe it's nice to show some hands or write in the chat if you know what GraphQL is. I would have an idea how much time I should take for this section. I don't see too many hands, so I'm going to assume not too many people know about GraphQL, or maybe they know, but they well, haven't used it in practice. So let's have a look about GraphQL. So GraphQL isn't really a framework or a programming language. Most of all, it's what we call a query language for APIs. So it's more of a protocol or specification than it's actually a language or a framework, or actually well, something has very strict guidelines. It's most of all it's specification, and you can find the specification on the GraphQL website. There's a cool website called graphql.org. It is the GraphQL specification, which is it was created quite a long time ago, and I believe a month ago, maybe a little less, it was updated, which is very cool to see because the foundation is growing. Because GraphQL, to give you some background knowledge, it was founded in 2012 or 2013 already by Facebook as an internal tool, because Facebook was on the rise in 2012. For the Netherlands, we still had Hives, but in the US, they were already working with Facebook. And they noticed that mobile devices were getting more and more popular among their users. So people started to have smartphones, maybe even very slow smartphones. Bandwidth wasn't that good. You maybe had 2G or 3G. So they noticed one problem, that it was really hard to consume REST APIs on mobile phones. And they could, of course, alter the REST APIs, so they would have something that would be fitable for the mobile phone. So instead of sending all those typical REST APIs that you have on a browser, they created specific REST APIs for mobile phones. But soon they found out it wasn't too scalable to do this, because then you have to maintain more and more endpoints. So then they came up with an internal tool called GraphQL, and I believe they had some working titles for it internally. There's a really cool documentary about it. If you would Google the GraphQL Conf documentary, it gives you a nice idea about how they actually came up with it. And in 2015 or 2016, they actually open sourced it. And then just 2 years ago or 3 years ago, I believe Corona sort of made my idea for time a bit different. So 2 or 3 years ago, they created the GraphQL Foundation, which is a subsidiary of the Linux Foundation, to make sure that Facebook isn't the sole maintainer of this project, and make sure that's being maintained by the community. So to get back to the query language, so GraphQL is following the specification, but it's always up to the person that creates the GraphQL server or the GraphQL engine to make sure that the specification is being adhered. So to give you an idea what this looks like, this is something called the Graphql Playground. There are many different flavors for Graphql Playgrounds. You have the main one, which is called GraphQL. You had one maintained by Prisma, which is a company that's very active in the GraphQL space. They had something called the GraphQL Playground. And this is another form that people created themselves, because most of the things for GraphQL are open source. Specifically, everything in the foundation is open source. And then a lot of tooling, what created by other people, is also made open source. So on the left side, you can see an example of a GraphQL query. And a query is an operation type. And there are roughly 3 operation types in GraphQL. You have queries, which you can compare to a GET request for a typical HTTP request. You have mutation, which is to mutate data. So queries are read-only, and mutations are if you want to change things. And mutation is mostly, you can mostly compare it to maybe a put request or a post request or even a delete request. So mutations are used for all these kind of things. And then the last one is a subscription. And subscriptions are to keep track of updated data. So you can compare it with a WebSocket or real-time data. It follows the same format as a query or a mutation, but instead of being pushed only once or being executed once whenever you want it, they will be looping on the background, watching for changes. So it's a bit like a WebSocket. And these operations types have all follow the same format. So you would define the operation. So here you can see the operation type is a query. It has a name called GitHub Queries. And then the operation name of the operation itself actually is GitHub_user. It takes an argument, which is a login name, which is GitHub teacher. And then it has a bunch of fields. So the top level name is always the query operation type, followed by the query name, which is optional, by the way, but it's it's advised to do so, because if you don't name your query, it will be really hard to be tracing it in the backend or in any log files you have, or even in caching. And then the second field you'll see is the operation itself. So the operation is GitHub user. It takes the argument, like I said, and then it will return a bunch of fields. And you can see there's even a relational field, but I will tell more about relational fields later on. And then on the right side, you can see that the data that's being returned is following the same format as the request that we did. So opposed to REST APIs, where typically you would do a request, maybe to a get endpoint, you have no idea what will be coming back unless there is an open API or a Swagger spec, which is often also not very well maintained. So a lot of people build APIs, they build specifications for those APIs, but often they don't keep them. They keep them in line, unless you maybe have a library or a different tool to do it for you. So this is one major upside of GraphQL. So as soon as you start sending the request, you already know what kind of data will be returned. And it always reminds me of this meme on the Spice Girls. So GraphQL is really tell me what you want, what you really want, and it will be returned. It's a bit like the song you might remember from the old days. So now we know GraphQL is a query language for APIs. What else is good to know is that it offers a single endpoint for multiple resources. So for a REST API, you typically have to send, I don't know, maybe 1 to 3 requests in order to fill the UI that you have. For GraphQL, it's different. So one request can have multiple resources, and they all accrue to the same endpoint. So you have a GraphQL API. It typically has only one endpoint, unless you chose to maybe have a backend for frontend in there, or maybe you chose to do your authorization on the endpoint level. Those are things you can of course do if you want. But typically a GraphQL API is a single endpoint, and in that single endpoint you can get multiple resources at once. It looks a bit like this. So this is another query. So this is a query to get information from Twitter. Specifically, it's a Twitter search one, and it will query for all the tweets that have the word Einstein in it. You can see edges are returned and nodes, which are typical to GraphQL APIs. Not all GraphQL APIs, but typically GraphQL APIs that are based on graph-based database. So we used to have relational databases. Then it was quite popular to have NoSQL databases or document-based databases. The trend from the last 2 to 3 years, I think, is to have graph databases. And these graph databases will define relationships a little bit different than relational databases or document-based databases. But in the end, it's very comparable. And in these kind of databases, you often have edges and nodes, and this is where data will touch each other. So for typical GraphQL API, you could see them implemented, but it isn't necessarily the case. But still, if you look at this query, you can see there's also relationships. You can see the relationship author is also in here, because the information from author is coming from somewhere else. So if you would have a typical REST API structure, and Twitter used to have REST APIs, and there are some cool blog posts to find on them and how they actually restructured most of the things to GraphQL in order to make it easier for them to consume data on the front end. But you can see previously they had a REST-based architecture, and in that REST-based architecture, they had different endpoints for different microservices or different database tables. So if you would be finding a tweet from someone, you typically have the tweet information, like the text and the created date, and then the information from whoever wrote that tweet would be coming from a different microservice or a different database. And in GraphQL, you can define those nested relationships all in one query. So you don't have to do separate calls to separate endpoints. Instead, you change your query and do just one call to one endpoint. And what's happening in the GraphQL server is something you can't typically see. So we're now just looking at a GraphQL API, but you have no idea what's going on under the hood. So maybe it's all coming from the same table. Maybe it's coming from multiple tables. Maybe it's even coming from different microservices. That's something you don't see in GraphQL, but it is something that your user or the consumer of your API doesn't really care about. So they just want to consume your API. They want to see your product. They want to send API requests, or they want to push on buttons. So for your user, it typically doesn't matter where your data is coming from. So that's a nice advantage you have with GraphQL. You can also hide the underlying infrastructure to your users, because maybe they don't have to know that everything is just in one table, or they don't have to know that you're actually running a monolith, or maybe you just don't want them to know that you have this whole microservice architecture in place. So GraphQL is a nice way to abstract all these kind of things and have just one entry point for everyone that's using your API. Either that's external people, internal people, or just your users that are clicking on buttons. And then the most important part for today's talk, at least, so it's very nice to see that GraphQL has a query language. It's offering a single endpoint for one or multiple resources, but most of all, it's based on a type system. And this type system is something that makes it really powerful, because it is really what's the biggest difference with REST API. So for REST APIs, you could have a RESTful API or a REST-ish API, and you can still implement things however you want, because REST APIs typically don't really follow a specification. They just follow the developers creating it, or the architect designing it, or maybe the information architect designing it. So for GraphQL, it's different, because we have the actual type system that's intertwined with everything that you do in GraphQL. So you won't have any outdated OpenAPI specs. You won't have any outdated Swagger specs. Instead, you will have a GraphQL schema, which is all the types that are available for your GraphQL server. And the schema, you can introspect it on multiple ways. The easiest way to understand what a GraphQL schema is either by looking at the code and finding the actual schema code, or by using GraphQL Playground. And this playground or interface, or whatever you like to call it, in there you can not only send queries and watch it results from operations, you can also find documentation for this API. And this documentation is typically auto-generated by GraphQL itself. So whenever you watch the playground will create the documentation for you. So some people also say that GraphQL is self-documenting. It's kind of the case, because you need to write your schema, you need to define all the types that are in there, you need to make sure that it follows whatever is in your database, and then you can extend it with whatever info you want. So on the right side, you can see there's also some extra information per type. So these are all fields that are defined for this query or this operation. And then you can see it also has additional information, so like a description below the type. And these are things you would have to add yourself. And a lot of people don't add this to their schema, which is perfectly fine, because if you're the only one consuming your GraphQL API, it doesn't really matter whatever is in there. But if you have external people using it, you maybe have different teams using it, or you maybe just want to make sure that it's documented for a handover, maybe you're handing it over to a different client, then it can be really useful to add these extra definitions in your schema. And then something else, well, if you are on Twitter, one of the most heated discussions is if GraphQL is better than REST. And I have opinions about it. A lot of people have opinions about it. But most of all, it's often seen as a replacement for REST, which I understand, because GraphQL API is a specification. REST API doesn't really have a specification, so it's an improvement. But that said, REST also has a lot of advantages, because for caching, it's easier to cache REST APIs, because you only have to cache one endpoint and see what kind of status code has been sent to there, what kind of body. For GraphQL, it's almost the same, but instead everything is a post request. So it can be a bit confusing when people first start using GraphQL. But it's good to know that it's not a one-by-one replacement. It's just actually an addition. So this is something that's, well, nice to know and nice to understand. And then I need to turn off whatever is doing this. Yes. Yeah, so the two can typically coexist side by side. And if we go back to the type systems by TypeScript and GraphQL, because that's the main focus point for this talk. If you have any questions about REST versus GraphQL later on, maybe we can do it in the QA part, or maybe you can just send me a message on Twitter or anywhere else. So GraphQL and REST can easily coexist. But if we look at the type systems of TypeScript and GraphQL, we'll also be finding out that they aren't too different. The type systems are very alike. There are differences, of course, but they are very alike. And if you know these subtle differences, then it's really easy to navigate between the two. So this is a overview of a type created in TypeScript and the type created in GraphQL. You can already see there are some differences. There are also similarities. So most of all, the way you define them, so it's almost the same. So both will start by defining a type. Then you'll enter name. You will open with curly brackets, and then it follows some sort of JSON-like format. So if you are working with JavaScript or TypeScript or JSON in general, it looks quite understandable. Maybe even for GML people in here, it might be a bit weird because it's not really, well, it's a combination of many things if you look at it from different standing points. But if we look at the similarities, you can see, well, both define a type, both list the name. And they both have basic scalar types. So they both have sort of default types that are there for every integration. So TypeScript comes with certain predefined types, which are like a number, a string. And then, of course, you can create your own type. So you can see we create a type called product. So this is a type you create yourself. But in TypeScript, you also have types that are predefined, that are already in the specification for TypeScript. And the same goes for GraphQL. There are types that are already being defined by GraphQL, and we call them scalar types. There are 5 or 6, and an integer is one of them, string is one of them, float. You also have ID. So these are examples of types that are already there for you. You don't have to do anything. They are there right in the spec. But of course, you can also create your own types, which is something that you can do in both languages. And by creating your own type, you can also have these types relate to other types. So on the left side, you can see we have a categories field for the type product, which has a relation, which is the type category. And then in particular, it's an array of category. And there are multiple ways to define arrays in TypeScript. You can either add the array brackets to the end, or you will type array and then define category within the array. So there are multiple ways to do it. This is my preferred one because it's the easiest one. It's the least amount of characters, even though having less characters isn't always better. But still, this is one way to create relationships in your type system. So both the categories field for both the product type in TypeScript as the product type in GraphQL they have the return type of category and specifically an array of category. And the same kind of relationship you can see for review. And then another similarity, which is also a big difference, is all the fields that you define for a type in TypeScript are required by default. So you can see the last one, reviews, it has a question mark defined. And by setting a question mark, you will make it optional. So in general, everything is required unless you tell it's optional. And for GraphQL, it's the other way around, which is interesting if you want to combine the two. So all the types that have a exclamation mark at the end, these are required. So a type is optional by default, and whenever you define it's required, it's required. And it makes a lot of sense because GraphQL is typically at the database level, and you don't want all the data from your database returned. You only want the data returned that you're using. And TypeScript is typically either at the server level which you can use it, or it's at the consumer level, your client. And if it's at the client level, it makes perfect sense to only list the types that you would expect in your application. So there it will make perfect sense to make everything required by default and then define if this should be optional or not. So how can you combine the two? So, and this is also what I will show in a short demo later. So how can you combine TypeScript and GraphQL? I think well, you already have an idea how we can do this, but it all starts by a CLI tool called GraphQL Code Generator. And this CLI tool will look at your GraphQL schema, and based on your GraphQL schema, it will generate TypeScript types. And this is really cool because that way, as soon as you have a server that's generating GraphQL, that's based on the GraphQL spec, you can run the CLI tool and get your TypeScript types created for you. Otherwise, which I will show in the demo, it's quite a lot of work to do this yourself, because of course you need to type everything yourself. You need to make sure that all the data is there. You need to make sure that you have everything included. And whenever you start updating things on the API, you won't know if it's broken unless it's actually broken in your client, because TypeScript will make sure that your client won't break based on the information it has. But as soon as your API changes and TypeScript isn't being informed that your API has changed, then you'll run into issues. So this CLI tool called Graphical Code Generator, it's very useful in order to make sure that your TypeScript types will follow the GraphQL schema. And for this, let's think about the type definitions from TypeScript and GraphQL again, because we just saw them. They're quite similar. They have some differences, but the differences are very minimum. And you can imagine it's quite easy to create a library that maps the default ones. So you have an integer, which you should map to a number. You have a string, which you should map to a string. This is all quite straightforward. But especially mapping the relationships, that's where it gets interesting. And even with Graphical Code Generator, you also have plugins, so you can already start creating even React components for you. And it all uses the GraphQL schema as a source of truth. So we should swap this around. So we no longer have TypeScript types first, but instead we have GraphQL types first. So Graphical Code Generator will look at your schema, which is also the best way to do, because your schema is typically at either the database or server level. And based on the schema, it will generate TypeScript for you. And it looks a bit like this. So on the left side, you can see the TypeScript that would have been generated for this type. You can see we have a sort of default type called scalar. So these are all the defaults, all the scalar types here from GraphQL, and those are mapped to TypeScript types. You can see ID is a string, which can also be a number, but it's something you already see in here, but it's something you can implement in GraphQL yourself. You can see string is a string. It's just the uppercase S that's different. For Boolean, it's the same. An integer and float, those are both numbers. And you can also see the type product is created, which has an ID, title, thumbnail name, reviews, all these kinds of types. And those are mapped to either the scalar types from GraphQL that TypeScript created, or to other TypeScript types that are a bit below in this field. So it all starts by mapping basic TypeScript types to scalar types of GraphQL. And this is something the CLI will do for you. And then it will also make sure that the relationships to non-scalar types are also still in there. So let's try it out by having Next.js and Graphical Code Generator to get some actual magic. And for this, we'll also be using a GraphQL API created with StepSen. And to create GraphQL APIs with StepSen, there is a quite a convenient tool called Graphql Studio. And in this one, you can create GraphQL APIs just by clicking. give you an idea about this. Let me go back to my other screen. So this will be an example of the studio, and in here you can actually select schemas. So the API we'll be using today, it has schemas from dev.to, which is also known as Practical Dev. So this is a website in which people use their as personal blogging platform. Then we have GitHub, and then we have Twitter, and we'll be mocking the data. So using this tool, you can already create a GraphQL API. You can just run this, run the queries, get some mock data. So this is all mock. But most of all, we get an endpoint. And this endpoint is something we can use in our React API or TypeScript app. And based on the schema that this one generates, so this is the Graphql Studio, it creates an API for you. And this API will give you access to the playground, or actually the whole schema. So we could actually curl this one right from your terminal and get the schema, get all the information in here. And this is something we will feed the GraphQL code generator. So GraphQL code generator will get the API that we created. And it can be a GraphQL API that you create with something like steps in GraphQL Studio. It can also be a GraphQL API that you consume maybe from GitHub directly, because they have a GraphQL API for that's being public. Or it can be a GraphQL API that you created yourself, because GraphQL code generator is able to handle all these kinds of things. And on the home page, you can actually see a live example. Let me maybe zoom in a little. You can see you have a schema. The schema has types in there, like queries, different queries, user type, a chat type. It could have operations defined. So if you would look here, so this is an example of an operation that you define, an operation that could be sent by your users. It's empty here. Then it has a YAML file which configures the code generator. It's asking you to create types only for TypeScript. And this is the output. You can see the mapping of the basic color types. You can see the mapping of basically everything here. So you can see expert type query, which is a mapping of this one. You can see a query called user. Let me try and find it, which returns the type user, which is the one you see here, which is also the same as here. So GraphQL code generator really helps you with this, and you can use it in just plain or vanilla TypeScript for all kinds of things. You can also use it with Apollo Client, React Query, which is a nice library to do state management in React. Also React Apollo hooks, React Apollo data components, which are deprecated, but they were very nice a few years ago, or Apollo for Vue, Apollo for Angular. All these kinds of things are types you can automatically create. And you can even work with MongoDB models. So if you're working with Mongo, it can be very nice to do it with GraphQL code generator as well. So we will be looking at some code for this. So I've created a small application that's doing just a couple of things. It is TypeScript, of course, and it's using Next.js. So if you're not familiar with Next.js, it's a framework for React applications, and I often prefer it over using Create React App, because it's very well, it takes away some of the pain that you have when creating React applications like routing, state management, server-side rendering. React can handle all these things for you. And something we can do in Next.js is doing a request to an API server side, which with this method. And what we'll be doing here, we'll be sending a request to the GraphQL API we created in the studio. It can basically be any GraphQL API. And we'll also be using a query. And this query is quite similar to the query that we saw before. It's also defined in this file. So you can see we have a query to get blocks from a user on Practical Dev. We can get a summary for them, a username. We're going to get some GitHub details from them, like their repositories, and then also some details on Twitter. So this is just a query defined in TypeScript. And whenever you define a query in TypeScript, you need to use GraphQL Query language, which is coming from GraphQL request in this case. but you can have a GraphQL query language from multiple APIs. There is also just the basic GraphQL package, which also has GQL, but it's probably named different. So we'll be using this operation in order to have our application running. And then, of course, we need to have types in our application as well, because we have a .tsx file, which means it's a TypeScript file. So .tsx is basically TypeScript for JSX. What we're doing here, we're using the library GraphQL request, which is a small wrapper around fetch, which will make it easy to do requests to GraphQL APIs. And we'll be giving it the query that we saw before. And we also give it an argument or a variable for an argument, which is the username, which is my username actually. But the data will be mocked, so it doesn't really matter. And then what I want to show you here is that we are working with TypeScript, of course, so we want to make sure we have types. And you can already see that the field data here doesn't have any type. If we would start this application, it will probably just run all fine unless we start giving it the wrong information. So I'm using Next.js, so I shouldn't be running yarn start unless I need to run yarn dev. And this is a small difference you have with Next.js and Create React app. If you were looking at the start scripts in the package.json, you can see you have dev to run Next.js in developer mode, and then you have yarn start or npm start to run it in actual production mode. And for that, you need to build it first. So something to keep in mind when using Next.js. And this will basically look like this. It's all mock data, so it looks a bit weird maybe in terms of naming. And what's happening under the hood, whenever you reload this page, you won't see any actual requests being done to an API, because what we're doing here is all server-side. So this is using a server-side request. But the thing we want to be adding here is actual props, because you can see not really props, but types. So you can see whatever is returned by data, it has the type any. The type any in TypeScript means there isn't any type defined. And I'm not actually sure why it doesn't complain. So probably I need to put it in strict mode. And there we go. Let's put this in strict mode. I probably need to restart my app. And then it's going to be requesting me to actually have types for everything I'm doing here. So now it should be starting to give error, so it's not really being used. So we can delete it, saying this is type any. See, it's not really giving me any trouble for it, but it is giving me trouble here. Because whatever is happening here apparently doesn't really matter to Next.js or to TypeScript, but whatever is being returned here is mattering to my React component. So my React component wants to display data, but it has no idea what the data looks like. So what you could do is create a type. So you can just start typing like type home props is this. So it is data. You can tell data what it is. So let's go back. And then we can just mark them off, right? So let's find what we have here. Do we have something simple? So we have data. So this is unknown, right? It's any. So we can try and type this one. So it maybe looks a bit funky, but that's because it's coming from the GraphQL operation. So devto underscore get user is actually the operation we have to find here. So this is something GraphQL always does. It returns the type with the operation also in there. But we can start typing it, right? So we have the username, and username probably, and this is a guess, it's probably a string. So let's say it's a string. Maybe we should give the home props to this one. So we're going to be defining whatever the type is. And now it will see this one as a string, which is actually good, because maybe if we, I don't know, maybe we want to do something strange like ×1. And then it starts complaining, right? Because we don't really want to do ×1 against a string. It would be a bit weird. And also maybe we want to say uString. Doesn't really complain, which because it's also already a string, of course. But these are just things to think about, right? So you don't want to be doing a string ×1. On the same side, you also don't want to have an integer that you want to display as a string. And then you can imagine that all these fields, having them defined, so you can see this also as any, which is something we don't want. And there are multiple ways to fix this. So we can say here, maybe title is a string. And then we probably stop complaining. But that's not really the case. So what we should be doing instead is also giving somebody to this one. So this slice map, so it's probably an array. You can just add them here to our type definition. So this was an array we thought, right? And then it would have something like title in it, which then probably a string. So now you can see also up here, it starts complaining. But we have way more errors we need to solve. So we're also getting information from other fields. It's getting quite messy already. And this is something you can also, you can also start changing. So maybe you even want to have type. And then in here, you maybe say type user is username. So you can go pretty far with this. So we can just copy this, put it here, say this is type user. And this will all still work, right? And we can do the same here. Now maybe create a type called article. Oh, sort of complain because we don't want to have duplicate things. Okay, get rid of you. Title. No, spell this right. Article. And then we should tell it that it has article and then specifically an array of article. And then this also works, right? We have no more complainant. Now it's a string. It knows this is an array. There are multiple ways to write it. As I said before, you could also do array, but like this. So these are two things, that are doing the same. So you can define them in both ways. Type typically before the second one because it's just shorter. But you can also do it like that. But you can imagine this is a lot of work, especially if you start changing things on your backend. So maybe you're going to start changing your queries. Maybe instead of username, you're going to get username somewhere else. Maybe you're getting username for GitHub instead. So you can imagine it can get messy quite fast. But luckily, this is where the compiler comes in. So we have GraphQL code generator. We have it defined. So it will take our schema, a remote schema actually. So it will be going to the same URL as we're fetching here. And here you can also see again, like all the field types it doesn't have. So it's super confusing for TypeScript to work like this, because you typically take away all the advantages that you would have for TypeScript. So we're going to use the code generator instead. We're going to get all the TypeScript files and we start looking for GraphQL stuff in there, which is not the most optimal way. Because you can also start looking for GraphQL files, which is a bit more optimal, but I wanted to use my query as a constant somewhere else. So we're going to be getting TypeScript operations and also GraphQL request, the library we're using to fetch this thing. And to run the generator, it's quite easy. You can just do yarn and GraphQL code gen. You can also create a script for it. It will start running the generator. So first it will parse the configuration, which is the YAML file. It will start generating the outputs. So first it will get your GraphQL schema, which is coming from this remote URL, the GraphQL API that we created before in the studio. Then it's going to start looking for my documents and then start generating output. And the output is generated in this file. So generates.ts. And in here we can see, tons of stuff being created because the schema is quite large. So the schema has all the information from GitHub, from DevTool, from Twitter. So let's focus on our operation instead. So this is the operation we have to get the queries by username. So this is similar to what we have over here because it parsed this file and it matched this file to our schema. And then based on this one, it created types for this as well. So here you can see steps and queries. These are all the types for operation. So you can see we have get user, which was the one we started defining here. The get user, it generated a type for it with the name, the string, username, all these kind of things. And it also created this for all the other types in there. So you can see, we can actually look at it like this. You can see it as get user, there's all these relationships in there, and this is auto-generated for you. And as soon as you start changing stuff, you can just run the CLI again, or you can run the CLI in watch mode if you're busy developing things. So let's try and see how we can use this to move faster. So what we can do, we can, an example, just import this one in here. So let's try our type. So whatever it was called, something steps and queries. Okay, this one. And then, yeah, so actually what we need to do is multiple things. So if we go back here first, so in here we can of course say data is of type steps and queries. Which is correct, of course, because our GraphQL API will be fetching this library will be fetching a GraphQL API with this query, and then it will return this type. And then you can see props here also gets the type. And then a small disadvantage of Next.js, it doesn't really see that this also has this type, which is understandable because well, we're getting them server side, and whenever you run this on the client, it could be that the types are different. But what we could do here is actually define home props and home props data. It will be this. So it will, oh, I copied the wrong thing. It will be this. So it will be our steps in. Steps and queries. And then home props, we can just put them in right here. And now we can just delete all these things because we don't have to define them all by ourselves. But what is happening, it will take this information from us. And then it will also know that sometimes the data could be empty. So maybe we just need to make sure that is data there? Is this there? So these are things you need to check for. And we only check if data is there at the root level. So we don't need to do this check. But it could be that username is undefined, because that's a possibility that our API said. And for title, it's the same. We should check if it's actually there, because it might not exist. And that's the interesting part, because it also depends on how our schema is defined. So probably somewhere in our schema, we said these things are optional. So if we would be going back to declaring our schema, you could also say in our schema, then probably the things that we want, like get the user, if we go here, we can find the type, ID. So if you go here, you can see the username. Where is it? Username. It is required, but for other things it isn't required. So you can see sometimes you get the error that something could be undefined, and that's whenever things are optional or not optional. And then for the CLI, it's, well, you can just run them again. So whenever you start changing things somewhere in your operation, then you can just well, regenerate them. So if you would delete this file, maybe you start changing things here in query. Maybe you want to add another field. We could go here. We could see whatever other fields are available. So get a user. Go to the type. You could say maybe the join that or the location is something we could add. If we just add a location here. Now maybe it's nice to just put this back because now we updated our query. You can just run the CLI again. It will load the documents, and then it will probably see your change because we added the location here to the query we're using in our front end. And then if we would go to generate, or actually to generate and see what are the differences, you can see that this field has been added. Also to our result return, the field should be somewhere in there. It's a bit sad that they don't format it. Maybe I can format it for us. Well, probably takes a long time because it's a lot of files. So that's a downside when you work with a large schema. Maybe up here, it's also being added somewhere. I don't know, you get the drill. You can just change your queries and then find out whatever it looks like. So to create a Graphql API yourself, you can go to the studio to find this code example or more. You can also go to GitHub /steps and samples. You can find this sample, but also other cool samples for GraphQL. You can also go to my personal GitHub, which is github.com/Derks, and then you can find well, even more GraphQL examples. And a question I always have, and I'm interested to hear if people have this question as well: should I start converting TypeScript right away? And every talk I gave about TypeScript, typically people in there were started to using TypeScript and didn't really see the advantage yet. Or it were people that wanted to get started with TypeScript and thought if they don't convert to TypeScript, they will be getting major bugs in their code. I think in the end, TypeScript has a major advantage, but you need to use it well. If you just type anything as any, then you don't really get the advantages. But if you do it correctly, then you have major advantages. But also be aware, as soon as you start renaming files to TypeScript files, then probably your whole code will implode because you'll be finding out that maybe third-party libraries aren't working that well with TypeScript. Maybe you need to create a lot of information, a lot of types for code you haven't been using for a long time. So always when people want to start using TypeScript, I always advise them to do it incrementally. Never convert your entire application to TypeScript directly. Just start working with things you're touching. So if you're changing stuff, if you're creating new features, try and see if you can implement TypeScript in there, because in the long run, it will really help you. It will decrease the amount of tests you have to write, because sometimes I see people writing tests where they check if something is a string or not. These are things TypeScript already does for you, and you don't have to write a single test for it. So it can have major advantages, but you need to do it wisely. You can't convert your whole code base in minutes. It's something that should be done incrementally. And most of all, even if you're not using TypeScript, maybe you're working with different languages, try to use a type system in there. So TypeScript has a type system, GraphQL is a type system because it has the lovely schema. But whatever you're using, try using a type system or a specification. Even for REST APIs, they are perfectly fine to use, but make sure that you're following a protocol, you're following a specification, and you're documenting your journey. So to get some more information about what we saw, just go to the TypeScript website, to the documentation. It's really good. It's really useful to get started and also to find out all the nitty-gritty things. I've been working with TypeScript, I think, for the last 3 or 4 years. And still, I feel like I'm learning new things whenever I go deeper and deeper, because it's really, there's a lot of things you can do with it. And it goes it goes from high level to low level. So there's something for everyone. It's quite nice to, well, find out all the hidden things that are there, and especially how powerful it is. So if you start building libraries for external companies, it's quite quite a challenge to find how you can type things in a way that it works well for everything. So for GraphQL, you have the graphql.org website, which has a lot of tutorials to help you get started. And the GraphQL code generator is, of course, something you can try out if you already have GraphQL and TypeScript. And for questions, I think we have more than enough time now if people have them. Otherwise, if you have questions you maybe don't want to ask right now, make sure to add me on Twitter and ask a question there. So thanks everyone, and please use the chat or unmute yourself if you have any questions for me. So thank you.
Yes, I have a question. Maybe can I ask it by microphone?
Yeah, sure.
Please.
Cool. Yeah, very interesting talk. Earlier you said that there is a trend going on with graph databases becoming more and more prevalent as a backend for GraphQL servers. What are exactly the advantages of using a graph database as opposed to, let's say, PostgreSQL in combination with Hazura or PostgreSQL or that kind of thing?
Yeah, so a quite popular graph database now is called FaunaDB, and they automatically generate a GraphQL API for you. And Neo4j is another example, but they are mostly used by large organizations. So the idea is that every part of the organization has their own graph, and these graphs can be interconnected, but they don't have to be interconnected. So you can think a bit about it as sort of a microservice model for databases. So whenever you have relational databases, you can get intertwined with other projects or other teams quite easily, or all these projects need to have their own database. But if you want to connect them, you need to build services on top of them to connect it. And with graph databases, it's easier to connect those graphs together. And it's also another advantage GraphQL has whenever you use it as a data layer for maybe your microservices. So one microservice could be directed by one team. They can build their own GraphQL schema, and then those schemas can be connected later on. But you don't have to touch anyone else's schema in order to make changes. So it's really a way to, for larger companies or for really decoupled organizations to work better together.
All right, and are there inherent advantages in the persistence layer between, I mean, as opposed to relational databases? Or I checked out Neo4j, for example, and the defining of the schema there is not quite as rigid in Postgres, for example. What are the trade-offs between? Maybe it's a bit out of scope, I understand, but what are the trade-offs between using graph databases and relational databases?
Yeah, for me, it's most of all the size of the organization. Because if you have just one team, then relational databases are fine. If you don't have that much data, or you don't have data that goes into the millions, then it's fine to use a relational database. So one of the biggest companies I know that is using a graph database is the New York Times, and they use it because every department, every part of the company has their own graphs. And previously, they all had their own database within a cluster, and then they needed to relate all these clusters together, need to make sure that there's some extra layer on top in order to aggregate results from everywhere. So it's really the size of your organization or the size of your project.
All right, makes sense. Thanks a lot.
No problem.
Zijn er verder nog vragen?
Hey Roy, first of all, thanks for the amazing talk. Just a question about, since we talked a little bit about microservices, I have sort of like an API gateway which connects to microservices that have certain GraphQL schema, and then I'm planning to use the code generator CodeGen tool. So is there a way, so say one of the microservices have apparently changed their schema, and then maybe the API gateway or another microservice that listens to this schema can get updated automatically or without having to trigger another introspection? Is there a way to do that?
Yeah, you have ways to do this, but I think then you will need to have maybe like a serverless function or something you need to call every time something changes. But still, you need to communicate with the other teams working with your API before you do these kind of things, because, well, if you try adding things to your GraphQL API that are in there or are making breaking changes, then yeah, it's something you need to communicate.
All right.
So in general, it doesn't really make sense to run the generator without updating the front-end code somewhere else.
Got it.
Because if you add a new field, then you need to make sure that field gets displayed, and if it doesn't, then well, it doesn't really make sense to update the types.
All right, thanks.